Hi, my name is Brad Jolly and I'm an application engineer for Keysight Technologies. Today we're going to talk about battery drain analysis on low power IoT devices using a DC power analyzer with a source measure unit and some special software. Long battery life is becoming especially important for Internet of Things devices, and depending on what estimates you look at, there will be anywhere from 20 to 200 billion Internet of Things devices connected by the year 2020. One area is wearables, and customers want battery life for convenience there. And another area for the IoT is remote sensors, where customers often expect 10-year battery life or even more. The device we're going to use today to test battery drain is the N6705 DC power analyzer with the N6781 source measure unit, or SMU. It has 4 slots, up to 600 watts, and has more than 30 modules that you can put in it. It features seamless ranging and 0.025% plus 8 nanoamps accuracy, up to 18 bits and 500 million readings per data log with 0 burden voltage. The device under test, or DUT, that we're going to use today is a wearable device tracker. It has low power sleep modes and operating modes for taking and storing measurements and RF communications. Let's take a look at it on the N6705. Okay, let's take a look at the instrument. The first thing we see here is channel 1, and I can turn on or off a channel right here. There are 4 channels on the instrument. I can set up my source options over here, my measurement options over here, and then the general instrument options can be set over here. I can auto scale simply by pressing the trigger button, and you'll see that it auto scales. And then I have knobs similar to an oscilloscope here, where I can adjust either the horizontal or vertical resolution. I can also move the waveform up or down and right and left by using the appropriate knobs. In this case, I'm just going to auto scale to get it to a reasonable value. You'll notice that right now it's running in scope view. I can also change it to meter view, where I can see the individual channels as numeric values, or I can go back to the scope view. Let me go ahead and stop it, and then if I want to zoom in, I can simply take my horizontal and turn it right or left, depending on which way I want it to go, and then I can do the same thing vertically, depending on what level of detail I want to see. The real exciting part, however, is the 14585 software, which has features specifically designed for battery drain analysis. So here's the 14585 software, and it's connected to the same N6705 that we looked at a minute ago. I'm going to start the scope mode right now, and you can see that it's operating much like an oscilloscope would. There are also 2 other modes that we're going to look at today, the data logger mode and the CCDF mode. Let's start with the scope mode. What I can do here is I can use auto scale, and that will automatically scale in both X and Y. And if I want to change it, I can later go over to here and change the horizontal scale, or I can change the vertical scale over here. Notice that I can also turn on the voltage signal and or the power. In this case, since it's a battery operated device, the current and the power are proportional, so I'm just going to leave this in current mode only. Let me go ahead and stop the scope for right now, and then I can zoom in using this button here. Click there and just go ahead and zoom in, and you can see that I can get pretty good detail like so. Okay, so that's the scope mode. Then I can also pan right or left right here, and I have the ability then to change to see how much I'm looking at any given time. The data logger mode will allow you to log data, just as the name suggests. You simply specify the duration here, the name for the file, and whether you also want to record the minimum and maximum values as you go along. In this case, I'm just going to leave it at 20 seconds, and let's click on data log, and it will start a data logging session. And as you can see, it's got a counter here that tells how much time has passed. At the end of the data log session, it will automatically write this file here, as you'll see in a second. Okay, so if I click here for the browser, you'll notice that there is a data log 8 file right there. What's really useful for battery drain analysis is the CCDF, or complementary cumulative distribution function. Let's take a look at that. It's very similar to the data log mode in the sense that you specify the duration and the name of the file. Let's go ahead and just run it. You can see the counter here. And it's showing the cumulative distribution function, but it's showing it kind of upside down, and that's why the C for complementary. Okay. Notice that it's a log scale. Okay, so the way you would read this is if you look at it, it appears that 90% of this is 600, about 500, excuse me, microamps and less. So what that tells you is about 90% of the time the output is 500 microamps and below. And that's what you would expect for a device like this, which has a large sweep mode. You can in fact change this from log to linear, but for an IoT device, it's pretty much a square, and so it's usually most useful to leave it as log. So in conclusion, the N6705, along with the N6781 SMU and the 14585 software, is an easy-to-use solution for both sourcing and measuring. Its simple wiring, seamless ranging, and zero burden voltage give you visual and numeric insights into battery drain characterization of your device. Thank you for watching.